Hey students, I got a question about number 14 back in chapter 4, and let's see if I can help through that one. Okay, so here it reads. It says, Angels Falls in southeastern Venezuela is the highest uninterrupted waterfall in the world, dropping 979 meters. All right, so I guess the waterfall looks something like this. I'll just kind of make a square cliff, okay? And the distance it falls, huge, 979 meters. So that's the vertical drop. It says, ignoring air resistance, it takes 14 seconds for the water to fall from the lip, so up here at the top of the falls, to the river below. Okay. If the water lands 50 meters from the base, all right, so I'll go 50 meters. What is the horizontal speed at the top? Okay, so the water, I'm going to go in red, would be flowing along, and it gets to the edge, and it falls off. And so by the time it takes this 14 seconds to go all the way down, it continues to move in this x direction. In fact, that's probably the best answer I can give here for an understanding is remember that this whole trick to the projectile motion was to remember that the horizontal x's and vertical y motions are independent of each other. And that when something, in this case, continues off the edge, it begins to fall. So its acceleration is definitely 9.8 meters per second squared, at least if we ignore air resistance, as they say to do. And then the other thing is that horizontally, there is no acceleration. So in other words, when it falls off, there's the effect of gravity. And the lesson here for chapter 4 was a continuation of the previous chapter where we said the acceleration due to gravity, or maybe that was chapter 2. So, yeah, I think it was chapter 2. Well, and we learned that the acceleration due to gravity was 9.8 meters per second in the downward direction, so the y only, and it was nothing in the horizontal. So that's really the key to the problem. It's to do one-dimensional motion twice. All right, so this is what I would know, that how far does it go horizontally? So let me go distance, would equal to velocity horizontal multiplied by time. And I guess we can kind of do the same kind of thinking for the y motion, but this problem doesn't go that far. I don't think we need to do anything in the y motion, and that's really kind of the main point here of this was, to ask for its horizontal speed, and you could spend some time working on the vertical motion, but it's not needed. Maybe after I get the answer, maybe I'll come over here and do something. But here, we just know horizontally that it goes 50 meters. We know there's no acceleration. That's why we used this equation. If we didn't, by the way, use this equation, we would have to do something more like distance equals to initial velocity plus final velocity divided by 2 multiplied by time. Or if there's no initial speed, we've got that other formula, 1/2 at squared. Okay. And so if there was an acceleration, we would have to, factor in a beginning and ending speed. But in this case, there is no beginning or ending speed. So it's just speed times time. Okay, and then the time is the 14 seconds. And so maybe I'll put a meter. Anyway, so it's pretty easy then to just grab the calculator here and go, it's 50 divided by 14. And so we're looking at 3.57 meters per second horizontally. Okay. Now, by the way, as a side note, not needed for this problem, but maybe to emphasize the learning skill here, that for projectile motion, the key was we can do horizontal and vertical motion separately. And so we just did the x. Let's see what we could do with the y. because in the y direction, once the water goes off the end, we could say vertically it has no speed. And then it gains a vertical speed. But having no initial speed is what this equation was all about. And so let's use that one here. Distance in a vertical direction would be 1/2, and the acceleration is 9.8 meters per second squared, and it's for 14 seconds. So in a vertical direction, 1/2 times 9.8 times 14 squared would tell us that it would drop 960 meters. Now, interesting enough, that is a little off from what they say it would. So maybe I should do the reverse. Maybe I should say, all right, if it fell 979 meters, what would the time be? So I'll put a 1/2 and a 9.8 and time squared. So this would be 978 times 2 when I bring this over. Then divide by 9.8 and take the square roots, and a more accurate description would be it takes 14.1 seconds to drop all the way down. So they were just kind of rounding it, and so that rounding near the end when it's going fast ended up being off by, looks like 19 meters. So, well, anyways, I hope the y part didn't confuse you. That's not necessary. This is the easy part of it. Just a 50 here, a 14 here, and you'll get the horizontal speed. Hope that helped.